Math Minute 96. Number one says 3 months ago, Janelle weighed 90 pounds. If she gained an average of 4 pounds per month, what does she weigh now? So we're talking about 3 months. And she gained an average of 4 pounds each of those months. So if I did 3 times 4, that would give me 12. So gained 12 pounds, and then she started at 90. So to get what she weighs now, I add those together. And 12 plus 90 would be 102. So 102 pounds. All right, number 2 says when you divide fractions, you actually flip the blank fraction and then multiply. So let's just draw an example. So if I had 1/2 divided by 3/4, what I would do is I would take 1/2, I'd change the multiplication, and then I would flip that second fraction. So it'd be 4/3. So you flip the second fraction and then multiply. Number 3 says how many 1-inch cubes can be placed in this 4-inch cube. So if it's a cube, that means all the sides are the same. So that's going to be 4, and then that's going to be 4. So basically what I need to figure out here is what's the volume, what's the amount of space inside the cube. And remember, the equation for volume is base times width times height. And in this case, since we're talking about a cube, it's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And if they're 1-inch cubes, that means that I can fit 64 1-inch cubes inside there. So we're going to say 64 cubes. Problems 4 through 5 use the chart to the right. Why do these numbers have arrows drawn between them? So if I look at these numbers, and if I took these numbers to the second power, I would get these numbers. So what I'd just say, the numbers on the left are taken to the second power. So for example, 3 to the second power is 9, 4 to the second power is 16, 5 to the second power is 25, and so on. That's a connection. And then number 5 says, which number in the first column could have gone in the second column? So 4 actually could go over here, because if you had a 2 taken to the second power would be 4. So 4 could actually go in either of those columns. Number 6, if 2a minus 4 equals a plus 1, then what's a? So I'm going to draw this out over here. 2a minus 4 equals a plus 1. So the first thing I need to do is I need to get these a's on the same side of the equal sign. So that means I got to get rid of one of them. I'm going to get rid of the a. So to get rid of positive a, I would subtract a. And I got to do that on both sides. So now those cancel out. So now I have 2a minus 1a. Well, that would give me 1a minus 4 equals 1. Now again, I'm trying to figure out what a is, so I need to get rid of this minus 4 right now. So I'm going to add 4. So those cancel out. So now I have 1a equals 5. And then to get rid of this 1 that's in front of the a, I would divide by 1. So a would equal 5. Number 8 through 10, use the diagram to the right. It says this piece of paper was 8 inches by 10 inches before the corner was torn off. What was the area of the paper before the corner was torn off? So remember, area is length times width. So this is going to be 8 times 10, which would be 80 inches squared. That's the area of the paper before the corner was torn off. Number 9, what is the area of the corner that got torn off? So this is telling us the dimensions of the corner. So like this little corner here got torn off, and it was 2 by 2. So the area of a triangle is base times height divided by 2. So for this, we would do 2 times 2 divided by 2. Well, 2 times 2 is 4. 4 divided by 2 is 2. So the area of that corner is 2 inches squared. And then what is the actual area of the paper without the corner? Well, I would just subtract these now. So I would just do the 80 before the corner was torn off minus the area of the corner, and I get 78 inches squared. All right, so go ahead and turn that one in.